Good evening, mom.
Good evening to Gagan Sai. Today is the 9th class mathematics chapter number 8th chapter quadrilaterals. Today we will learn the exercise 8.3 9th problem. Okay, today we will learn it in this page. Before the 9th problem, today we will learn the 8.6 one theorem. Today we will learn it, the midpoint theorem of a triangle. Telangana State Book page number 188 and 189. Today we will learn the one important theorem. Based on this theorem, today we will learn the 9th problem. So first of all, today we will learn this theorem. What's the midpoint theorem of a triangle? This is the very important theorem, Gagan Sai. Be carefully, listen better, neatly. Okay, are you understood of the previous class?
Yes.
1 to 8 problems, it's over in this exercise, 8.3 exercise. Are you any doubts? No doubt. Shall I start with the today class? This is the 8th chapter quadrilateral notes, theoretical notes. Okay. Okay, today we will learn this theorem only, 8.6 theorem. The midpoint theorem of a triangle. What's the theorem? This theorem statement. First, I will read the statement. This theorem statement. The line segment joining the midpoints of two sides of a triangle is parallel to the third side and also half of it. Okay. The line segment joining the midpoints of a two sides. First, let us draw the one triangle, ABCD triangle. The line segment joining, this is the line segments. Okay, the line segment joining the midpoints of two sides of a triangle. Two sides, AB sides and AC sides, midpoints. E, F, these two are the midpoints of a triangle is parallel to the third side. This is parallel to the third side and also half of it. This is the statement. Okay. Let us prove this theorem. Yeah, this is the figure. Okay. First, given. Given equal triangle ABC. Okay, in triangle ABC, E, F are the two midpoints. E, F are the two midpoints. Look at this notebook, Gagan side. Be careful, listen better, neatly. Are the two midpoints. Midpoints of a two sides. Two sides. What's the sides? AB and AC, sir. AC respectively. AB and AC sides. Next, required to prove. How to prove this one? What's the proof? Here it is. EF is parallel to BC. EF is parallel to BC. First question. And next, second one is EF is equal to half of the BC. Okay, parallel to the third side and also half of it only. So these two I have to prove this one only. How will you prove this one? One by one. Let the solution for this theorem. Yeah, first proof. Proof. What is given? That in this theorem we need to a one construction. What we needed in this theorem? We needed a one construction. What's the construction? EF is extended to D point. And next, draw a one parallel line. Here it is, draw a one parallel line. And EF line segment is extended to this one. These two are lines meet at point D point. Okay. So it is formed a one square is formed here. One triangle is formed here it is. Okay. Here it is that point. You write it here it is only. Given here it is the AE is equal to BC. BE. Okay. And AF is equal to FC. Why it is equal? These two. This is the midpoint only. So that's why AE equal BE. And given also that point is also you write it here it is. AE equal to BE and AF equal to FC. Okay. In proof you write it. Construction you write it. What's the construction? Join EF. Then EF, E comma F and extend it. Extend it and draw a one parallel line. Draw a one parallel line. Parallel line. This is the draw a one parallel line to BA. BA through C. Okay. C through draw a one parallel line. Through C. Here it is. So one triangle is formed. So one triangle is formed. What's the triangle? CDF. Triangle is formed. Okay, these two are meet at point D and so this triangle is formed here. It is. Okay. So now let us take these two triangles. What's the triangles? AEF and CDF. Let us take these two triangles. We will prove these. These two are the congruence. We will prove it only. Why it is take these two triangles? We want this side and this side is parallel or equal. We will prove this one only. So that's why we want these two sides. So that's why let us take these two triangles. Let us take it only. Triangle of, what's the triangle? AEF and next triangle of CDF. Now let us take these two triangles. In triangle of AEF and triangle of CDF. Okay, in these two triangles, what is given? What is asked? Here it is the AEF, triangle of AEF. So here AF is equal to CF. AF is equal to CF. Why it is equal these two sides? Here it is the AF is equal to CF. Why it is equal? F is the midpoint of AC only. Okay. Here since, what's the reason? Are you understood? F is the midpoint. Midpoint of AC. Okay. Next. Here it is. These two are is. Here it is the intersecting lines. this line and this line. Whenever the two lines are intersecting each other's vertically opposite angles are, is it equal? Okay, we know that point only. So this angle is equal to this angle only. And what's this angle? Here it is the AFE. One triangle is equal to CFD. Okay, angle of AFE is equal to angle of CFD. Why it is equal these two? These two are the vertically opposite angles. Are equal. Whenever the two lines are intersecting each other's, then vertically opposite angles are equal. We know that only. And next one, here it is the AB is parallel to CD. One construction here, draw here it is only. So that's why these two are is parallel and ED is the transversal. So alternate interior angles are equal. This angle is equal to this angle. Okay. What is this angle? AEF. One angle is equal to CDF. Okay. AEF is equal to angle of CDF. Why it is equal? Are you understood? These two are is the alternative interior angles are is equal. Or equal. Okay. Here it is the BA is parallel to CD and here it is the ED is transversal. Okay, this step you write it here also, otherwise here since also write it. Okay, anyone on. So now here we have side angle. So according to the angle, side angle ASA, according to the ASA congruence rule, these two triangles are is congruence only. Okay, are you understood? Therefore, what's the triangles? Triangle of AEF is congruence to triangle of CDF. Why it is congruence? What's the rule are using here? It is ASA, congruence rule. Congruence rules are using, these two are is the congruent triangles. So once check it, order check it. A is equal to CD and AF is equal to CF only. So here it is the, what's the AF? AF side angle side. So these angle side angle congruence rules, these two are is the equal only. So next here it is the AE is equal to CD. Why it is equal? These two are is the CPCT. And next one EF is equal to DF. EF is equal to DF. Why it is equal? CPCT. Whenever the two triangles are congruent, CPCT are equal only. So since these two are CPCT, by using the CPCT, these two sides are equal only. Okay, are you clear? And next CPCT also it's over. And next this one, by given problem AE equal to BE. By given problem AE is equal to BE. Okay. Here it is the BD. AE equal B. So BE equal, here it is the B, not BD. BE is equal to A in place of, you write it the CD one. Okay. Why? Because here it is these two are equal only. B is equal to CD. Okay, B is equal to CD. So B is equal CD means is the BE parallel to CD only. So BE parallel to CD. Okay, BE is equal to CD. It is means that this is the parallel to. We can draw here it is only one on construction. We can draw here it is only. So the A is parallel and B also parallel to CD only. Okay. So that's why the parallel are equal. So now here it is the BCDE. It is a quadrilateral. Quadrilateral, one pair of opposite sides are is it equal. This side and this side. So one pair in quadrilateral, one pair of opposite sides are is it equal, parallel. Then the quadrilateral is a parallelogram. We know that only. What's the parallelogram? BCDE is a parallelogram. Parallelogram means is the in quadrilateral both pair of opposite sides are also equal only. Okay, this side and this side is also equal or parallel only. So that's why first in quadrilateral is, what's the quadrilateral? BCDE. In quadrilateral, here it is the BE. BE is parallel to CD. Okay, and BE is equal to CD. So therefore, it is a BCDE is a parallelogram. Why it is a parallelogram? Are you understood? Here it is the one pair of opposite sides are is it equal only. So that's why it is a parallelogram. Here since also you write it one pair of opposite sides are parallel or equal. So that's why this is a parallelogram. This is a BCD, a parallelogram only. So parallelogram, in parallelogram BCD, in parallelogram BE parallel to CD, and opposite side is also, another opposite side is also equal only. What's this side is? Here it is the ED. ED is parallel to BC only. So ED is parallel to BC. Okay, and here it is also FD is parallel to BC also, this also. Why? Because this is also dry extended here it is only, this is the parallel only, parallel to BC also. So that's why here it is the ED is parallel to BC and FD is parallel to BC also. Okay, are you clear? Are you understood? In parallelogram, here it is the BC is, therefore BC is equal to ED. Why it is equal? These two are is the opposite sides. Opposite sides are parallel or equal in parallelogram only. So that point you write it. Since opposite sides are parallel or equal. So that's why these two sides are equal only. Okay, are you clear? Next, BC is equal to ED. ED means here it is, what's the ED? ED here it is EF plus FD. Okay. ED it can be written as EF plus FD. Why it is? Right here it is, this is the ED is equal EF plus DF. So that's why since this one. Next, EF plus DF. DF, it is nothing but EF only. Why it is? These two are is the equal sides only. So that's why FD in place of, you write it the EF. Okay, are you clear? So that's why EF plus EF, it is nothing but 2EF. This is the BC. BC is equal to F. We want the EF. EF is equal to, or 2EF is equal to BC. And EF, we want the EF is equal to, before equal, multiplication of 2. After equal, it becomes to the division of 2 only. So of BC. Okay, this is the second question. It is proved only. Okay, are you clear? Therefore, EF is equal to half of the BC. Hence, it is proved. Okay, are you clear? This is the second question. It is proved. What is the first question is? This is only B. EF equal to BC. Okay. Yeah, this is the BE parallel to CD. In this in quadrilateral, BE is parallel to, what's that? DC. And next another one is the EF is parallel to BC only, not ED, EF. This is the EF. Okay. So this is the first question, proved only. And FD is also parallel to BC. Okay. This is the first question, it is proved, and this is the second question only. So that's why these two questions is proved only. Okay, are you clear? This theorem? Yeah, very important theorem. This theorem is at home. Once again, you practice only the one side. Based on this theorem, today we will learn the exercise problems. 9th problem. Okay. Are you understood this theorem? Yeah, this is the very important. Okay. And next, let's see the problem in our textbook. See this side. Yeah, 9th problem. Let's see the problem in our textbook. Be carefully, listen better neatly. ABCD is a square. E, F, G and H are the midpoints of AB, BC, CD and DA respectively, such that AE equal to BF and CG equal to DH. Prove that EFGH is a square. This is the question. First, what is given, what is asked. First, I will explain this question. ABCD is a square is given. Okay, first draw a one square. ABCD is a one square and EFGH are the midpoints of this all are the four sides only, AB, BC, CD and DA. And AE, BF and CG equal to DH. This is also all of the sides are equal. And how to prove this one only? EFGH is a square. How will you prove this one? Very simple. This problem solution is the very simple. First given data, how to write it in our given problem. This is the given ABCD is a square. EFGH are the midpoints of AB, BC, CD and DA respectively, such that AE equal to BF equal to CG equal to DH. To prove or required to prove equal to prove EFGH is a square. Yeah, first this is the draw one square. This is the draw one square and EFGH. These are the midpoints of the sides AB and BC, CD and DA sides. Okay, next AE. AE is equal to BF is equal to CG and DH. Okay, these are sides are also equal is given. How to prove this one only? EFGH is a square. How to show that this is a square? How to show that? We will show that this one is a square from this figure. Let the solution for this problem Gagan sir. Be carefully, listen better neatly. From this figure, what is given from this figure? Here it is the ABCD. is a square. Is a square, and E, F, G and H are the midpoints of sides. What's the sides? AB, BC, CD and DA respectively. Okay, also this also are equal. This also sides are is it equal. What's the sides? AE is equal to BF is equal to CG equal to DH. Okay, these sides also equal. Yeah, proof equal. In here it is the in square AC and BD are the diagonals only. Okay, that point is also given here. It is only. It is the AC and BD are diagonals. Okay, in square AC and BD are diagonal. Diagonals are equal and perpendicular to each others. We know that only. Okay, this is the perpendicular to each others, bisect to each others, and diagonals are is it equal only. So AC and BD diagonals are divided into how many triangles are is divided here? 4 triangles. Total is the 4 triangles. This is the first triangle ABC, one triangle, and next ADC, another triangle, and here it is another triangle is EDC, third triangle, and BAD, fourth triangle. Okay, these two diagonals are divided into how many triangles are divided? 4 triangles are is divided only. One by one. Let us take these two triangles. Let us take one by one only. First, in triangle of ABC triangle, let us take triangle of ABC. Okay, first in triangle ABC. Okay, in triangle ABC, E, F are the midpoints. Midpoints of sides. What's the sides? AB and BC sides. Midpoints of sides AB and BC sides respectively. Okay. And next, sides are is it equal, and EF is parallel to AC. EF is parallel to AC. Previous theorem, midpoint theorem. This side is EF is side is parallel to the third side only. Okay, this is the third side. So parallel and off of it only. So that's why EF is equal to AC. So EF is equal off of AC. Okay, are you clear? Yeah, this is the equation number 1. And next, another triangle. In triangle of ADC triangle. Here it is the GH only. GH is G, H or the midpoints. Midpoints of sides. What's the sides? CD and DA sides. CD and DA sides respectively only. So that's why GH is parallel to, what's that? GH is parallel to this third side. Third side is the AC side only. So here it is the GH is equal off of AC. Okay, this is the equation number 2. From equation number 1 and 2. Equation number 1 and 2, we get it. What we will get it? What we will get it? Here it is the EF is equal to GH is equal to half of AC. Okay, half of AC equal to EF and half of AC equal to GH. So that's why EF GH equal to half of AC only. Yeah, next another, let us take another these two triangles, opposite triangles. In triangle of, what's the triangle? BCD. Triangle of BCD. Here it is the F comma G. F comma G are the midpoints. Midpoints of sides. What's the sides? BC and CD side. Okay, respectively. And here it is the FG is parallel to, what's the parallel? This side, BD side. Okay, BD. So FG is equal to half of the BD one. Okay, since what's the theorem? Previous theorem, midpoints theorem. So half of it only. So this is the equation number, third equation. And next another triangle. Let us take another triangle. What's the triangle? Triangle is opposite triangle. This is the BAD triangle. BAD triangle. In BAD triangle, what's the H comma E or E comma H? E comma H or the midpoints. Midpoints of sides. What's the sides? Here it is the AB and DA side. Okay, respectively. So EH is parallel to, what's the BD? So EH is equal to half of the BD. This is the equation number 4. From equation number 192. Equation number 3rd and 4 only. It's a 192, it's over. So 3rd and 4, what we will get it? Okay, what we will get it? FG. FG is equal to EH is equal to half of BD. Okay, half of BD is equal to FG and half of BD is equal to EH. So that's why these two are is it equal to half of BD one. Okay, are you clear? Next, this is the continuation. Third problem solution, continuation only. And next, in these two questions, what's the EF GH? EF equal to GH is equal to half of BC. EF equal to GH is equal to half of AC. One. And another one is FG is equal to EH is equal to half of BD. FG is equal to, what's the EH is equal to half of BD. Okay, are clear? In these two, so that's why here it is the diagonals. Diagonals are is it equal? In square, diagonals are is it equal? AC is equal to BD in square. In a square, diagonals are is it equal? We know that. Okay, in square diagonals are equal. So what's the diagonals? AC is equal to BD diagonals. Here it is the either this one or this one. Let us take any one only. So let us take this one. EF is equal to GH. AC. AC is equal in place of BD also. You write it only. Okay. Let us take this one only. Either this one, anyone. So AC in place of, you write it the, what's the AC in place of BD also. AC equal to BD. So that's why you write it the BD. So here it is the GH equal to EF. And here it is that EF is equal GH is equal to half of BD. It is nothing but what's the FG is equal to EH. So that's why FG is equal to EH. Are you clear? Are you understood? Since here write it AC is equal BD. Okay. Next half of BD is equal to FG is equal to EH. So that's why these all sides are all are the equal only. What's the equal? EF is equal to FG is equal to GH is equal to HE. Okay. These all are the sides are is it equal. So all are the four sides are is it equal. What we can say? Yeah, either it is a square and rhombus. In a square and rhombus, all are the sides are is it equal. All are the angles are is equal only. We know that only. So here it is all are the sides are equal. So what we can say here it is a rhombus. So what's the rhombus? EF, FG, GH. EF, FG, GH, HE. All are the sides are is equal. So this figure is a either rhombus or square. So rhombus. So therefore EFGH is a rhombus. Okay. In rhombus one angle is 90 degrees. Then it is called a square. Okay. What we want prove here it is EFGH is a square. It is proved only. So rhombus, it is all sides are is it equal. It is a rhombus only. In rhombus one angle is 90 degrees. Then it is a square only. So we have to prove that one only. So here all are the sides are is it equal. In rhombus this is a rhombus. Oh, and here squares. And in rhombus diagonals are perpendicular to each other only. Okay, diagonals are perpendicular to each others. So that's why 90 degrees. Each angle is 90 degrees only. Here it is. All are the 90 degrees is formed. So here this is the 90 degrees. And here this is a parallel only. This is a parallel to AC is parallel to EF. And here it is the BD is parallel to EH. So that's why this is parallel to this one and this is parallel to this one. So what is this quadrilateral? This is the, let us take, this is the IJ. Okay, IOJE. Is it a quadrilateral? Yes, it is a quadrilateral. It is a parallel. Quadrilateral, it is nothing but parallelogram. Why? Because here it is the one pair of opposite sides are equal. This is parallel to this one and this is the parallel to this one. In quadrilateral, in two pair of opposite sides are is equal only. So then the quadrilateral is called as the parallelogram. Okay, it is a parallelogram only. In parallelogram, one angle is 90 degrees. Here it is. Opposite angles are equal. So here it is. This angle is also 90 degrees. Okay. Do you know the properties, Gagan side? We know that properties only. And in rhombus is also this. In rhombus is also opposite angle is also equal only. So angle of G is also equal. In rhombus, adjacent angles are supplementary or consecutive angles are supplementary. So here it is the angle E plus angle F is equal to 180 degrees. So angle F is also 90 degrees. This side is opposite angle is also 90 degrees. all are the sides are is it equal, all are the angles is also equal. What about this figure? It is a square. Yes, is it a square only? This is a rhombus. EFGH is a rhombus. One angle is 90 degrees. So right angle only. So it is a square. Simply is also it is a square. Otherwise is all of the sides are is also equal. All of the angles is also equal. What about that figure? It is a square. EFGH is a rhombus. So in rhombus diagonals are perpendicular to each other. AC is perpendicular to BD. Since diagonals are perpendicular and bisect to each other. In rhombus or square also. Okay, rhombus or square also. Okay, AC is perpendicular to BD only. So here it is in parallelogram. What's the in quadrilateral? It is a quadrilateral. What's the quadrilateral name? In quadrilateral is, what's the quadrilateral? O. Here it is the IOJE. IOJE is a quadrilateral. In quadrilateral, what's the both pair of opposite sides are is it equal? So IE is parallel to OJ. IE is parallel to OJ and equal also. Okay, and next, and this is also IO is parallel to EJ. IO is parallel to EJ. Are equal also. Parallel and equal. Quadrilateral, these two sides are is parallel or equal. So it is a quadrilateral. This quadrilateral is a parallelogram. So therefore IOJE is a parallelogram. Okay, are clear? In parallelogram, what's the? In parallelogram, what's the parallelogram? IOJE. In parallelogram, opposite angles are is it equal only. What's the angle? Angle of, here it is the IOJ. Angle of IOJ is equal to angle of opposite angle. This angle on opposite of this one. JEI. What's the angle? Angle of JEI. Why it is equal? These two are is the opposite angles. Opposite angles are equal in parallelogram. In a parallelogram, what's the parallelogram? IOJE parallelogram, opposite angles are equal. Okay. So these two angles are 90 degrees only. Angle of IOJ is equal to angle of JEI is equal to 90 degrees. So why it is equal to 90 degrees? Are you understood? These two are the opposite angles is equal to 90 degrees. So here it is the angle E is equal to 90 degrees. In rhombus, angle E is equal to 90 degrees. One angle is 90 degrees. So hence here this one is IOJE. Simply is also write it. Otherwise, some more also steps is also write it. First is simply write it. Okay. Hence in parallelogram, what's the quadrilateral here? It is the IOJE. quadrilateral is, what's the quadrilateral is? IOJE. Here it is the, not IOJE, quadrilateral. Here it is this quadrilateral and EFGH. Quadrilateral EFGH. And quadrilateral is EFGH. All sides are, is it equal? All sides are equal, and one angle is 90 degrees. One angle is 90 degrees. So it is a square. EFGH is a square. Okay, are you clear?
Yes.
Otherwise, two more steps also you write it. What's the two more steps? Here it is the angle E is equal to 90 degrees. Okay. And next, in rhombus, what's the consecutive? Sum of the consecutive angles are supplementary only. So that's why angle E plus angle F is equal 180 degrees. Why it is equal to 180 degrees? These two are the consecutive angles. Consecutive angles are supplementary. Are you clear? Are you understood, Gagan side? Okay. Here angle E. Angle E, what's the angle E? Substitute this value, 90 degrees only. So angle F, as it is, write it 180 degrees. And this is the, we want the angle of F. So that's why 180 degrees minus 90 degrees is equal to, subtracting of these two terms, we will get the 90 degrees only. So angle E equal to 90 degrees. Angle F is also 90 degrees. Angle G. Angle G is, what's the angle G? This is the, in rhombus is the opposite sides are equal. So angle G is equal to 90 degrees. Why it is equal? This is the, since opposite angles are equal in rhombus. Okay. So that's why 90 degrees. So all are the angles is 90 degrees. So angle E is equal to 90 degrees. Angle F is equal to 90 degrees. And angle G is equal to 90 degrees. And another one is the, what's the angle? H is equal to 90 degrees. Okay. All are the sides and all are the angles are is equal. Okay, are you clear? All are the sides means is the EF is equal, FG is equal to GH is equal HE. All are the sides are is equal to, all are the angles are equal. So that's why, what is this? What about this figure? It is a square. So our answer, therefore, what's the triangle? EFGH is a square. Okay. Why it is a square? Are you understood? EFGH, all are the sides and all are the angles are equal. So that's why it is a square only. Finally, we can say this one only. Okay. In a square, if joined the midpoints of a square, then again also we will get a square. Finally, you can say that one. Okay, are you clear? This figure is also we get a square. This is the square and inside of the figure is also we will get a square. Are you clear? A square, if joined the midpoints of a square, then again also we will get a square. That is the very important thing. Okay, are you clear? Yeah, it is a square. This is the proof. It's over. Hence it is over. Hence it is full. Okay, are you clear? Yeah, this is the exercise. All problems and solutions is over. 8.3 all problems and solutions is over. Okay, this exercise is over. Are you any doubts today my class?
No doubts.
No doubts? Okay. Now tomorrow at home practice this question Gagan side. Okay. Say today's the class it's over. Say thank you. Have a nice day. Like, share and subscribe. I hope this video is helpful for you. Say bye.